Before we go to the video, let me show what's happening. We are measuring the Wi-Fi signal strength with an ESP8266. Let's go!
Jungle and Python, JavaScript, tutorials for Jamie, this is Silva.
What the fuck, HTML?
There's only C.
Hello everyone and welcome to another video. Today we will measure the Wi-Fi signal strength with an ESP8266. So this stands for RSSI, which stands for, again, for the received signal strength indicator. And it's measured in or expressed in decibels. So the value is going to be negative, and the closer to zero, the stronger the signal is. I've put in here a table with some of the values that we can expect, and assume that we have something between -30 and -50, then we can expect the signal quality to be excellent, and so on and so on. When it goes below -80, it's not that good of a signal, very weak. So for this video, what you will need is an ESP8266 board. It can be any of them, as long as it has an antenna, a Wi-Fi network, and Arduino IDE or something similar that you use to program your ESP board. And link in the description. This post is in my blog. If you want to follow from there, you are super welcome. I'm gonna drag this to my other screen and follow from there the code, which is quite simple. Let's open the Arduino IDE, and we basically will split this in two steps. We will need to connect the ESP to the internet, and after that we will read the RSSI. So first thing, let's include the ESP8266 Wi-Fi module or header file, and then we need to define a couple of chars. Let's make it const char pointer SSID to be the name of your network. Similarly, the same thing but for the password. Okay, I'm gonna fill this later, so I'm not sharing this with everyone. Once you have that, let's go to setup and start the serial. I'll begin. Let's put it 115/200 for the baud rate, and let's print line so it looks more clear. Now it's a matter of connecting this to the Wi-Fi. So the typical thing for Wi-Fi connection, Wi-Fi dot begin, pass in the SSID and the password. We can put some message connecting to the internet. I'm gonna keep it simple. And while Wi-Fi dot status is different than WL underscore connected, we will wait with a delay of 500 milliseconds. 500 milliseconds, and for making it more clear to the user or to us, let's print a dot every time we wait 500 milliseconds. Okay, once we are past this, we can assume that we are connected. Let's make this simple. /n for new line, and then say connected. That's part of it. We are connected to the internet if everything is correct. And part 2 is going to be reading the RSSI. So we can create a variable for this, RSSI for a long Wi-Fi, and it's a matter of using the function. let's print it with serial print f signal strength. Let's put between parentheses RSSI. It's going to be percentage LD dBm, new line, and finally pass in the RSSI. End it with a column, and let's put a delay of 1 second so we can keep track of this. Select your board with an ESP1. So for me, it's going to be generic ESP8266 module, port 8, OK, and it's a matter of uploading it. I have a typo in here, so let's take care of that. It's like this. Re-upload, and should be working now. I will be recording this with my camera so we can have a better feeling of the signal. Let's open this on the serial with Control Shift M, and it's printing. Here's my router, and yeah, the closer you get it to it, the stronger the signal, so it gets closer to zero. There's some interesting things that go on in here. The signal seems to be stronger around the board when it's sitting horizontally, and if you put it like this, the signal seems to be a little worse. Obviously, the more distant it is from the router, the worse it gets. And yeah, there you go. Measuring your Wi-Fi signal strength with ESP8266. I hope you had fun with this video. It's an interesting feature, and yeah, like, subscribe, say hello, share, and I hope you have a great day. Bye.